Hi and welcome to Geeks for Geeks. Today we would be solving the problem named as levels of game. Now, now in this problem we are given a health and a money and we need to find the highest level that we can reach. So now what is the initial level? The initial level is 0 and you need to get to the maximum level that you can go. But there are some conditions. Okay. Now, the first condition, suppose you are at a level n and you want to go to a level n plus 1. Suppose the initial is 0, so you want to get to a level 1. Okay, the same kind of example and in the formula. If you want to do this, then you have three ways to do it. The first way is that the health would increase and the money would also increase. The second way, the health would decrease by 5 and money would decrease by 10. In the third path, in the third way, the health would decrease by 20 and the money would increase by 5. Okay. So now the most profitable way would be taking the first way or the path that is referred to as in the question, and then we can proceed. But wait, this is not it. Okay. There are some more conditions to it. The conditions are that you can't take the same path for consecutive levels. Like suppose I took the first path, then in the second iteration, I can't take one. Okay, but I can take 2 and 3 because it is not taken initially. So suppose I took the second path, then in the next level I can took this first and the third path. Okay, now when will we stop? Okay, like when we would stop, like we would keep going, and we would stop when either health or the money becomes negative. Okay, and suppose we have something like this, suppose we have 5 and then we have 7. Okay, or let's take a more preferable value which would work on the level that is given. Suppose we have 0 and then we have 1 and then we took the path 2. Okay, that is health would decrease by 5 and minus 10. So this would be minus 5 and this would be minus 10. So this would boil down that minus 5 and this would be minus 9. So this from here to here we went to negative. So this won't refer to as leveling up. Okay, this won't count in the leveling up. Like suppose you were at position 5 at this point, then after this point also you would be at position 5 if you use the second path, because by using the second path we reached a negative value and that current won't count. Okay, okay, this was the summary of the question broken down into pieces. Now let us move forward and try to solve this. Okay, so there are three paths. The first path is having this, and the next path is doing this, next path is doing this. Now let's try a greedy approach, or you can say that let's try a way where we would be getting the maximum value or the maximum level at each point. Okay, so how can we do that? So it seems that if we start at level 1, so the next one, which one we would choose? The next one, if the m is more, we can move forward with this. If the m is less, we would move forward with this. Why? Because if m is more, we can afford to have minus 10 damage after 1. If m is less, then we would simply add up that m and we would afford an damage on h. But it would be very much difficult to process at a particular point in which path should I take. Like, like suppose it is 0, suppose it is 100 as well as 100. So it has ample supply of P2 as well as P3 as well as P1. Now we can't really decide that which one to prefer. Like suppose even if we prefer in this order that yes, P1 would be preferable, then we would use which one? Suppose we went to P1, then if we use P1, this one would become 103 and this one would become 102. The first one is the health and the next one is the money that is provided. So if we use this, then we have more health. Then we can afford to have damage over the health So we would use this. But suppose the solution doesn't have this, but it tells us to have this. Why? Because the difference is just by 1. So it might be the scenario that using of P2 at this position is more preferable than P3, but to us it seems that P3 is more preferable. Why? Height is greater. So we can't really decide which one to choose at each step. So whenever we can't really decide which one to choose at each step and we are given a number of options, then the best thing is to see all possible see all possible ways, and then return the maximum. Return the maximum. So we see all possible ways, and at the end we return the maximum. So this is how we can proceed. So see all possible ways. Whenever you come across this conclusion, this means that you need to use recursion. Okay, like complete search or these all things, these all terms you have, then the first thing that should click in your mind is by using recursion. Okay, so recursion. So in recursion, we talk about the base case. Then the next step, that is the recursive step. Third one is the parameters. Okay, so let us talk about the base case initially. So what would be base case is every time the smallest case that can be handled by ourselves. Okay, smallest case that can be handled by ourselves. So the smallest case can be of two types. The first one can be 0 0, like either of them is 0. So still we can process something, like if it is 0, we have h plus 3 or m plus 2. We can have this p1. So can we do more? Let us see more lesser, because the lesser opportunities the base case would have, more easy is to write it. So the first we saw that if it is positive, we have numerous option. If it is 0, then we have little bit less option, but still we have one option. Okay, so now let's move to the third one, which is negative. Suppose height is negative or money is negative. If either of them is negative, we would return -1, that this level won't count. So we can say that if h is less than 0 or m is less than 0, we would return -1 at this position. Okay, so now comes the recursive part. How would we move forward? Suppose we are at a current step. Suppose we are at the level 5 and I want to reach the level 6, and we have some values of h and m. So if I have some values of h and m, there are probable conditions are that we can go in all possible 3 direction. Like we would take the first path, we would take the second path, we would take the third path. We can do it. So the first recursive step would be try all 3. Try all 3 paths. But the problem would arise when initially you have already tried the first path and now you are again trying the first path. Why? Because after this step you are again trying the 3 path. So what we do is we try all possible path except the last path. Except the last one. We try all possible path except the last one. So now let us see what are the things do we really need to calculate this. So we know that to have the base case, we just need the h and m. So in the parameters, we need h and m at each step. Now to have the recursive step, we will try all 3 possible paths, and the path values are already mentioned to us. So that is not an issue. But the problem lies that we need to see except the last one. So we need to see what was the last path we have chosen. So we can have a variable as last chosen. Okay, we can have this. Now this is how we would proceed. So we would have the base case, we would have the recursive step, and we would have the parameters. Rest everything would be discussed in the implementation. So now let us move to the implementation now. Now let us start the implementation. As the parameters that we need is not complying with the parameters that we have, so we would be using a wrapper function. So what would be the return type? The return type would be the level that we can reach. So the return type is int. Why? Because we can see from here the answer data type, the data type of the answer variable would be of int. So we would write int, and let's have a very small, that is f only. Okay. And then what all we need? We need the health, we need the money, and we need the last chosen path. So we would have health, we would have money, and we would have the last chosen path as C itself. Okay. Simple thing. Now we would write that if h is less than 0 or n is less than 0, what we would do is we would simply return a -1 value. Okay. From here it's fine. Now we would initialize a value answer. Now we know that the smallest value, the smallest level that we can have is just 0. So we would initialize the value of the answer as 0. And then we would start running behind the maximum value. Okay. So we would have this. So now to have this, let us see that. Okay. So now we know that if we use the first path, the height would be affected by 3. That is add 3, add 2, -5, -10, -20, -5. Now there are ways to do it. The first way is that we have something like this, that if h plus h added to 5, then m added to the next one, there, what was that? That was 2. And then we have all the values in the form of if condition. Okay, so we would have 3 ifs here. But there is a more organized way, okay, which would help you in debugging, and as well as it would help you to write less. So the idea is that what is the value that is being affected? So value being affected is if we use the path 1. Okay, so just see this position. If we use the path 1, then health would get affected by 3 and money would get affected by 2. And if we use the second path, the health would get affected by -5 and the money would get affected by -10. Where it is written, if you take the second path, the health decreases by 5 and money decreases by 10. So now let us take the third path, which is third path, health decreases by 20. So 20, and then the next one is increase by 5. So now what we can do is, instead of adding them explicitly, we would have this in the form of array, this in the form of array, and we would refer to this as index 0, index 1, and index 2. And then if we add, suppose this is h and this is money, and if we add h plus the value at 0, that is 3, value at again 0 of the next one array, that would give me the value, that is this one would be 2, that is h plus 3, m plus 2. So we would have this. So let's keep this array and then you would understand it much better. Okay, so now what we would do is we would have a simple dx is a dx, okay, and then dy. And this is a very common way to traverse in a graph. Let me tell you this. Okay, you would have seen in many coding arena. The first one would be 3. Okay, the next one would be -5. A third one would be -20. I told you this. We would have in an array the first one. Then we would have the next one, that is 2, -10. Okay, and then the 5 itself. And then we would close each one of them. And we would declare them globally so that we don't need to pass them again and again. Okay, so if you observe that if I add a value h plus dx of 0 and m plus dy of 0, so which would be nothing but dx of 0 is 3, and m plus dy of 0 is equals to 2. This is how we would traverse the first path. Now suppose we want to have the second path. So if we want to have the second path, we would simply add dx of 1 and then m plus dy of 1, which would help us to have h plus -5, and then this one would be m plus -10. It is -10. This would be h minus 5 and m minus 10, which is the value that we want if we take the second value. This is how this dx and dy is going to work, and we would implement this. So what we would do is, if we have taken path 1 in the past, then we would refer to as 0. If we have taken the second path, we would have referred to as 1. If we have taken the third path, we would have referred to as 2 itself. Okay, we would refer to as 2 itself. Now what we would do is we would start using a for loop. Okay, for, and we would iterate over all the path. Int I is equals to 0, I is less than 3, and I plus plus. So this is how we would try out all the path. Instead of having 3f, we can directly use a for loop that is already provided to us. Okay, so if I is not equal to c, that means the current path we are trying to do is not the past path. This means this. I'm telling you again, the current path that we are going to try is not the path that we have tried it last time. Okay. And we want the maximum value. So answer is equals to maximum of the answer that we had previously. And then we would have f of h plus dx of I, and then m plus dy of I. We would have both of them, and then we would have the current path. See, now if this path, this is the path, 0 means first path, 1 means second path, this means second, third path. Okay, so if I am currently able to use I is equals to 0, that means now my used path, last used path, would become I itself, and then we would simply add a value 1. Like we are able to get one level up. So we are going towards a path. See, this is going towards a path. So if we are going towards the path I, that means we are using the path I, so we are passing that. And if we are using a path, that means we are getting one level up, so we are just having I is equals to 1. Okay, at the end we would just return the answer itself. Okay, now let us simply call it. So what we would do is we would initialize the answer is equals to 0. Why did we do that? Now see, what will we basically pass? So this C, initially we can start from how many ways? We can start from 0, we can start from 1, and we can start from 2. These are the only 3 possible ways we can start the game. Other than that, there is nothing. So what we would do is we would start the game using this one only. So what we would do is for int c is equals to 0, c is less than 3, and c plus plus. Okay, then what we would do, answer is equals to maximum of, starting with the path. Suppose we started off the game with path 0 and it returned us a level of 1, it returned us a level of 2, it returns us a level of 3. So we are not at all bothered which path we are starting off. We can start off with any path. The maximum value matters to us. That is why we are storing the maximum. So this would store previous answer and then the current value, that is h and then m and then c itself. Whatever value it is returning, it would return as the value ans. Okay, so now let us see how many errors are we making. Okay, yeah, so this is coming correct for the sample test cases. Now let us try to submit it. Okay, so we are getting a time limit exceeding, so we need to optimize this recursive solution. So if we are told to optimize this recursive solution, then we need to, okay, optimize the recursion. So if we want to optimize the recursion, then we need to use dynamic programming. Okay, and how to do it? We can just memorize the recursive solution, and that would be done itself. So before moving forward, let us understand how this recursive code is working. Okay, let us understand the working of the code. Okay, now let us try to understand how this recursive code is basically working. So if you see that we are starting off with 2 and 10, then there are 3 ways we can move forward. The first one is by using the path 1, the second one is by using the path 2, the third one is by using the path 3. So if you use the first path, this is the health, this is the money. So if you use the first path, your health would increase by 3. That is, it would become 5. That is 2 plus 3 is equals to 5. And then 10. And then it would increase by 2. That is, it would become 12. Then the next one, if we use the second path, then it would decrease by negative 5. So 2 minus 5 is equals to minus 3. So this would become negative 3. Okay. And this would decrease by 10. So this would become 0. And then let's try to have the third path also. So if we use the third path, then the first health would decrease by 20. That is negative 18 it would remain. And then 10 it would decrease by 5. So 5 would remain. Okay. So now at this point, we can observe that this is negative. This is negative. So this path is not valid. This path is not valid. Okay. And if we are moving forward and we are going to any path, we were adding 1. If you observe it. Okay. Max of this and function of h and m plus 1. So we did plus 1 at each of the path we are moving forward. So at this point, when 1 becomes negative, it is minus 1. So positive 1 and negative 1 would make it 0. So by going in this direction, we received the value 0. We received the value 0. And this one would also have negative 1. Why? Because this would hit the base condition where this h or m is less than equal to 0. So we would simply have this. So plus 1, negative 1, that would have the value 0 from this point only. So now from this point, we are allowed to move in 3 directions using the first path, second path, and third path, because these are all null and void things. Okay. So now if we use the first path, it is not allowed. Why? Because we have came from by using the first path. So by using the first path, this is not allowed. So we would simply cross out this first path. Then let us try to use the second path. If we try to use the second path, this would become 5 and then negative 5. Okay, that is 0 and then 12 and then negative 10. That is what? That would give me a value of 2. And if we use the third path, it would be 5 and negative 20 is equals to, and if we use the third path, that would become 5 and negative 20, which is negative 15, and this would be 12. It would decrease by 5. That is 12 minus 5 is equals to 7 would remain. So now if you observe, this one would return me a minus 1 value. This one would also return me a minus 1 value. Why? Because here this is negative and here this is 0. So this would return me negative value. So here also we have added positive 1, but here also we would have negative 1. So this positive 1 has remained at this position and this negative 1. So 2 minus 1 would return 2. The maximum value we had is 1 itself. So we would have 1 as the resultant value. And this is how it is working. Okay, so now if we want to optimize the recursion by using dynamic programming, we can simply memorize the recursive. So if you do it for a bigger value, then you would see that there are overlapping subproblems. If there are overlapping subproblems, that means you need to memorize it. Okay, you can use dynamic programming over here. Okay, so now how to memorize this solution? Memoizing is, let us first understand what is memoizing. So memoizing is nothing but remembering the past event. So if you do it for a large input, which is not feasible at this small position, and if we do it side by side, it won't be that great understandable. So consider doing it on a big pen and paper. So if you see, there are overlapping subproblems. What do you mean by overlapping subproblems? That means that we are doing for same set of h and m again and again. So we don't want to do that. If we don't want to do that, we need to remember the value of h and m so that we don't again compute the value of h and m. So what we need to do is we need to save the values somewhere, which is just remembering the past events. Now how to do this thing? So let us take a screenshot of this. Okay. So to do this, it's absolutely very easy. First start by seeing the variables which are dynamic. That means the values which are changing, the variables which are changing, the parameters in the parameters. Let us see if h is changing or not. First one is h. So we can see that we are altering the h at this point. Okay. And other than that, we are not altering. So h is being altered. So this one would be h. H is being altered. Now let us do the same thing for m. I would pause as this minute. So let us move forward after the pause thing. So now m. M is also being altered at this point. See, m plus something. So m is also being altered. Let us see for c also. Here c, suppose it is 1. Then here it can be 0 and 2. Here if c is equals to 0, it can be 1 and 2. Okay. So we can see that the value of c is also changing. So all three values are changing. So that means we need a 3D data structure to store this, or a pair or something. Now what we need to do is to memorize this. We need to know what is the range of h, m and c. So what can be the values? So basically for h, we are going +3 or -2, these all things. Okay. For m also, we are also doing that same thing. And c would just be 0, 1 and 2. Okay. So this is fine. So if you observe, h is getting incremented by 3, -5 and 20. Okay. 3, -5 and 20. Okay. This one only. So if you observe that this negative thing, if it is getting on the negative side, then we are simply having a base case to handle that. So negative values won't occur. So we basically have values from 0 till the value of h that is given plus 20, okay, or plus 5 or plus 3 or something. So to be on the safer side, what we would do is we would simply have the value of h as it is given that 1000. Okay. So 1000, instead of that, we would have multiplied by 2 result. Okay, simply to have that, so that we even handle the cases of the addition also. Okay, so it is just like having the values 105. So it's better that we take 110 so that we don't fall into errors, because the small difference won't create a difference. That even if you take 1001 or 2001, the time complexity would remain the same. Okay. So that is why it is not happening. So this h and m would be 2000, okay, 2000 something, and then this would be again 2000 something, and the value of c is 0, 1 and 2. So we would do the same thing, 0, 1 and 2 again. Okay. So this is how we would save the value. Okay. And then we would see how we are doing this. Okay. So what we would do is, now we know what kind of array do we really require. We know that we do require a 3D array. So we would have int dp of 2020 to be on the safer side, like 2020. Okay, this won't make a difference, 2020. And we know that c's value would be 012. 012, that means we need a value of 3 itself. Okay. Now we would initialize all these values as not calculated initially. So what we would do is we would come here and then we would have a for loop for int i is equals to 0, I is less than 2020 and I plus plus. We would just fill up the 3D array with -1. So for int j is equals to 0, j is less than 2020 and then j plus plus, and then we would have again the same thing for int k is equals to 0, k is less than 3 and then k plus plus, and then we would say dp of I dash j and then k is equals to -1. That not a single value is calculated at this point. So now after the base case, before the calculation, we would first check if the value is already stored or not. So we would simply say that dp of h and then m and then c. If it is already calculated, that means it is not having the value -1. If it is not having the value -1, that means it has already been calculated. So we would simply return dp of h, m and then c itself. Okay. And if we are coming down, that means the value is not calculated. So just before returning, save the value h, m, and then c is equals to the value answer. So we would start from either of them, and I'll just compile and run and see how many errors are we making. Okay, seems no errors for the sample test case. Now let us try to submit it and see if we get an AC or not. And yes, we got an AC. Just a small bit of implementation trick that you can use. You can comment of this. Suppose you are very tedious to have like 3 nested for loops here. So what you can do is you can simply use a memset of dp comma -1 comma size of the dp itself, which would fill up the dp with the value as -1. You can use this trick if you want to initialize the dp with 0, 1, and -1. Now let us see and try to submit. And yes, we got an AC again. That is what you can use this small implementation trick that you can use in your code. So now let us talk about the time complexity of the solution. Calculating the time complexity of the solution is absolutely very easy. This one is of h, okay, and this one would be incremented n times. So h multiplied by m multiplied by c. And we know that this is a constant, that is 3. That means it is h into m, which is nothing but n square, which is the desired time complexity. And if we talk about the space complexity, it is also the same, the array itself. And these are the two desired space and time complexity. So that's it for today. Thank you and have a nice day. If you face any difficulties regarding the understanding of this question, feel free to raise your doubts in the comment section. Thank you, everyone. And it takes a lot of effort to make this video with all these explanations and dry runs. So consider leaving a feedback if you think that this effort is commendable. Thank you.